Welcome to section 1.2, Training versus Inference. This is a fundamental concept in artificial intelligence, and understanding it is critical for anyone working with AI systems. In this lesson, we'll break down the difference between building a model and using that model, two phases that shape every AI application you'll encounter. By the end of this section, you will be able to clearly define training and inference, explain how they differ, and identify the distinct compute and performance requirements of each phase. You'll be able to relate these concepts to practical examples, such as spam classification, and recognize how they may be tested in exam style questions. This section focuses on two critical phases of the AI lifecycle: training and inference. Training is when the model is built, while inference is when the model is applied. Each has different requirements and constraints. To illustrate these differences, we'll walk through a spam classification example later in this lesson. The training phase. Training is the process of building the model. Here, the algorithm learns patterns from data. Training datasets may be labeled, such as spam versus not spam emails, or unlabeled, where the model identifies structure without explicit guidance. This phase requires significant compute resources, often GPUs or TPUs, because of the sheer scale of operations. Training is usually performed offline or in batch mode. It may take hours, days, or even weeks. The end result of training is a trained model that can be deployed for use. The inference phase. Inference is the process of using a trained model to make predictions. This happens in production environments with real-time or near real-time data. For example, when a new email arrives, the system runs inference to classify it as spam or not. Here, performance constraints are different. Inference must be fast, with low latency, and able to scale to high throughput. Instead of maximizing accuracy at all costs, inference systems are optimized for efficiency and responsiveness. So this slide summarizes the main difference between the two. Training is about building the model with massive datasets and heavy compute. It's done offline, often in research or development environments. Inference, on the other hand, is about using the model in the real world. Here, the priority is responsiveness, scalability, and cost effectiveness. While training may take days, inference must often happen in milliseconds. Now let's bring this to life with a concrete example, a spam classifier. During training, the model is fed millions of labeled emails, some spam, some not. This training process is done offline and produces a model that understands email patterns. Once deployed, inference happens in real time. Every incoming email is classified as spam or not spam. This must be fast and reliable so users don't experience delays in receiving messages. Alright, so to summarize, we covered five main concepts. First, the AI lifecycle is divided into two phases: training and inference. Training builds the model from large datasets, often using powerful compute resources in offline settings. Inference applies that trained model in real time to new data, with efficiency and low latency being critical. Finally, we reinforce these concepts with a practical spam classifier example. Together, these ideas form a foundation you'll need both for the exam and for the real-world AI system design. We've now completed section 1.2, training versus inference. You should be confident in distinguishing between these two phases of the AI lifecycle. Take a moment to review your notes, and when you're ready, we'll move forward to the next section and continue building your expertise.